Okay, now let's solve this using a Python program. What I've got here is the Python program we use to calculate radioactive decay, and I'm going to modify that according to the general principle of never start from scratch if you can piggyback off an existing program. So the program starts off by importing the plotting package and math package. We can leave that intact. Now we need to pick the starting conditions. Now we're counting over height rather than time, so instead of having t equals 0, we have h equals 0 at the beginning. We're not counting the number of particles, we're doing the pressure, so let's have pressure equals 101,000 at the surface. Now instead of a time step, we're having a height step. And let's say we're having 100 meters as a height step. Now with the lists to store the values, the plot can remain the same. So now we need to set up a loop. Now in this program we were looping over time. Now we're going to loop over height. We have to set a stopping condition. In this case, for example, let's stop when we get to 10 kilometers up. We could stop higher or whatever, but that will be one sensible stopping condition. And now the crucial stage. We need to work out the change in pressure, dP. Now we know our equation for this. It's minus density times G times dH. Now, I might want to put in some constants up here, so let's pick G equals 9.8. Also, what's the density going to be? Well, the density is going to depend on the pressure. We've got an equation for that, so let's put that in here. Density equals P divided by our constant C, which is 84.0. Some of these numbers I'm going to put point zeros over it so that Python knows it's a decimal number, not an integer. It's generally good practice if something's going to be a floating point number that's to say it's going to have fractions, decimals. You should put a point zero afterwards to tell the program that's what's going to go on. Not strictly necessary, but often a helpful hint. Okay, so we've now worked out the density, which is based on the pressure, and we've worked out the change in pressure to go to the next step up. So we'll calculate the quarter step. Now we need to update. So we update the height. Height equals height plus dH. And pressure equals pressure plus dP. So we'll give us the new values. And then we're going to store whatever we plot. So let's say we want to plot the height against the density. So store the height and the density. That should do it. And we'll change the plot to plot it as a green line like it actually says rather than red crosses. Minus for a line, G for green. And we'll just change the axis labels so they match. So there'll be height in meters on the x-axis. And density in kilograms per meter cubed. The dollar signs here are just special terminology that Matplotlib, the package we're using, deals with to plot mathematics. Okay, we'll save that and run it. Let's see what happens. Seems to be working.